Welcome back, students. In the previous video, we talked about antiderivatives and indefinite integral in terms of notation. A little bit of theory too, but mostly notation. Now let us focus upon computation. Here's a reminder. The power rule: add the power by 1 and divide. Precisely the opposite of the derivative computation. Special case: when negative first power. The previous rule will not apply because k plus 1 is 0 and 0 cannot go to denominator. So special case is here, x to the negative first power, in that case log function. Exponential always stay the same, so here we go. These are standard antiderivative rules that we are going to exploit, but please remember a little bit more extended form. Very similar to these three, but here we have ax plus b inside the k power, ax plus b inside the negative first power, and ax plus b inside the exponential. And what's the recurring theme here? A in denominator. I'm highlighting them in different color here. A in denominator. That's a recurring theme. B doesn't play any role, but this coefficient A goes to denominator. When A is 1, in that case we have just these rules. Nothing to divide by, or dividing by 1 but no change. So these are a little bit more extended form. The reason, as usual, we can simply start from the right hand side and then simply take the derivative. Calculate this derivative using the chain rule. Calculate this derivative using the chain rule. Again, use the chain rule. You'll see. Well, okay, let's do just one computation. I leave the other to students as an exercise problem. Okay, how does this thing work? Derivative of this plus c, that'll disappear because that's going to be 0 anyway. Alright. This is coefficient, so stay there. And then we have to multiply by power, which is k plus 1. And then we have to subtract 1 from the power. And then by the chain rule you have to multiply the derivative of the inside. What is it? What's the derivative of ax plus b? That's a. And then what do we get? This k plus 1 will cancel out with this k plus 1 in denominator. And this a by chain rule will cancel out with this a in denominator. In the end, what do you get? Ax plus b to the k power, precisely what we wanted, the integrand. You can do the same thing to the other problems as well if you want to prove these formulae. Now, if you forget about these proofs, it's still okay as long as you remember how to use this a. They just go to denominator. And that applies not only to standards power function and exponential function, but to trigonometric functions and other functions as well. We're going to talk about trigonometric functions in a separate video. Let's talk about more standard problems here, and I think we can do most of these in this video, probably not all. Okay, let's start from something simple. Integral of x to the third power plus 3x squared minus x. Oh, by the way, if you miss this parenthesis, that's not really right, because after all dx is kind of multiplication, so applies to this x dx, but how about the others? You see, that kind of causes a problem. So to be a bit more precise, you need this parenthesis there. As for that missing parenthesis, I usually don't take up points for that, but still it can cause confusion to yourself, so better to have all these parentheses. Alright, let's work out the antiderivative. Antiderivative of x to the third power, what is it? Raise the power by 1 and divide. Simple. 3 is coefficient, so stay there. And x to the second power, raise the power by 1 and then divide. Minus x, raise the power by 1 and then divide. And we have plus c. Now, I'd rather stop here, but if you want to simplify, you can go ahead with just a little bit more simplification. This 3 times 1/3 will cancel out, and then that's going to be the final answer. If you go to my notebook and open up, yeah, the final answer, they're the same. How about the next problem? Okay, let's work this one out similarly. Oops, wrong key. Okay. We have to use a power rule. 5x to the 4th power, nice. Okay, let's work it out. 5 times, raise the power by 1, and then divide. That took care of the first term. Now, how do we do this one? We have this radical answer 1. As a matter of fact, you can change this into power form. This is x to the first power, and this is effectively the same as x to the 1/2 power. The square root is the same as 1/2 power. Now the same base, multiply. What you can do is you can simply add up the powers. Kind of like this. A to the m power times a to the n power is equal to a to the m plus n power. An exponent rule. Remember this? So this middle part becomes, as a matter of fact, 3/2 power. Let me emphasize this in a different color. So if you take the antiderivative of this, 2 was coefficient, which was there before, and then raise the power by 1. So add 1 to the power, 5/3. And then you have to divide. Dividing by fraction, that's the same as multiplying by reciprocal. Let's emphasize this in red. So you see the difference here? This is the original problem. I changed it into power form so that I can apply the power rule. Usually the power form conversion is the first step. Now let's go over to this e to the 4th power. What is this? Is this an exponential function? So it remains the same. The answer is no, not really. This blue part is not right. It's not an exponential function. There's no x in there. So e to the 4th power is actually a constant. So the antiderivative of constant is the constant times x. So this x pops out here. You can simplify this a little bit. 5 times 1/5, and then this. If you do that, you're going to get this answer. Tricky. You can convert the power form, and then please note that the exponential part is a constant. Okay, I don't need this anymore. Here's the answer. Enough time for maybe 2 more problems. Okay, let's see. How about this one? The last thing you should do is to take the antiderivative of this and antiderivative of that and multiply it together. It doesn't work like that. I think I already gave you a warning here. You see, you can separate addition, yes, but the product, no, you can't do that. So what do you do? My suggestion, break apart. Use FOIL method. So how does that thing work? First, 1 times 2, and then outside, 1 times t squared. Now inside, minus t times 2. And then finally last, minus t times t squared. You can simplify this thing if you want to. Well, I'd rather go without simplification. Antiderivative of 2 is 2t. Next, raise the power by 1 and then divide. 2 is coefficient. Raise the power by 1, so t squared, and then divide. Finally, raise the power by 1 and divide. That's good. But if you want to simplify this thing a little bit further, you can change this into descending order. And then plus 1/3 t cubed minus t squared plus 2t. Okay, this is a final version. I'll count this one as final answer, yeah, but a little bit further simplification certainly improves your answer. Well, here I gave you a warning, the product rule doesn't work that way, and then I hit the answer here. Okay, here's the computation. Somehow I like this answer better because I did a bit of a further computation in descending order, so that's a little bit more desirable. Okay, enough time for just one more problem. Alright, let's consider this problem then. How do you do this? We have the second power, but you can rewrite this thing as 2 minus square root of x like this, and then FOIL it over just like we did in the previous problem. First, 2 times 2 is 4. Outside, -2 square root of x. Inside, another minus 2 square root of x. And then finally last, square root of x times another square root of x. That's just x. And if you simplify, you're going to get 4, and then these are the same. So 4 square root of x, but it's better to write this way as 1/2 power. And then let's finish our computation. Antiderivative of 4 is 4x. 4 is coefficient, and then what do? Add 1 to the power, and then divide. Add 1 to the power, and divide. We're using the power rule over and over again. Add 1 to the power and divide. This is complete, but if you want to simplify just a little bit, maybe changing into descending order, yeah, okay. 1/2 x squared is the biggest, and then next 8/3 x to the 3/2 power plus 4x. Okay, I don't know whether this change of order is really necessary or not, but hey, here we go. It's a descending order anyway. What did I do over here? I didn't bother simplifying. Oh yeah, I just go ahead without simplification. Alright, we are nearly done, but we left out these two. We'll have to do these in the next segment of the video. See you soon.